Hello, this is Dr. Raz. In this video, I would like to go over calculating errors, type 1 and type 2 errors for hypothesis testing. And I log into our class Blackboard 2.9. And here you should be able to see the CSV file, 20 coffee shop loyalty.data.csv. Three dots, download original file. And then you can click on that file to open it up. And you can see here that we have 60 observations and 30 of them are control variables where there's no loyalty app usage. And then the remaining 30 of them loyalty app usage. And you can see the average weekly cups of coffee purchases in column C. Now, what I would like to do is I would like to download my Python file, three dots, download original file, and then go to Google Colab, click on Google Colab, open Colab, upload, browse, find the file. Okay, this is not the right file. Let's do it again. Upload, browse. Then here, files. Waiting for it to connect to runtime. It's taking so long, so I'll refresh it. And try again, files. Still taking a little bit of time. Okay, upload. And upload CSV file, coffee shop. Okay, let's first import libraries, pandas to deal with structured data, SciPy to do T statistics. And to calculate type 2 error, you can see we use t-tests in Power. Run. Let's create data frame called data by reading the CSV file. Again, make sure that the name of the file matches, three dots, rename file, Control C, and then highlight this area and Control V. Run the code, and now we'll divide our data set into control set and loyalty app set. And if the group column is control, then we'll record the average weekly purchases under control. If the group column value is loyalty, then we will record the average weekly purchases under loyalty. So we calculate T statistics and p-value based on the loyalty data, control data, and we will assume that the variance is equal because when we calculate the standard deviation of the both data, they are very similar to each other. And it's a one-tail test where we are trying to see whether loyalty app will improve the sales. And we'll print the results, and you can see the average sales was 3.39 cups before the loyalty app, and that increased 4.03 cups after the loyalty app. And you can see the p-value associated with this is 0.000, pretty much close to zero. That means that we can reject the null hypothesis that they are equal. In other words, our data suggests that the loyalty app improves the sales. And if you look at t value associated with this p-value is 4.5, which means that the difference between these two numbers is 4.5 times of what we would expect from just randomness, which we call standard error. We chose alpha 0.05, and we check to see whether if p-value is less than alpha. In this case, yes. So again, we reject null hypothesis. In other words, it's evidence the app increases purchases. So now we can just run this code to be able to calculate and estimate the type 2 error, and can print the results. You can see that the type 1 error it's like alpha 0.05. So risk of false positive, which means that we assume that there's a chance of 5% chance of assuming that the app will be helpful for the sales improvement, even though it's not. And a type 2 error beta is 0.2%, which means that it's false negative. In other words, that there's a 0.2% chance that we won't launch the app, even though we should. I want to see trade-off here. What if I just change the alpha from 0.05 to 0.01? If I just run this all the code again, you can see that the alpha will obviously go down, and that means the type 1 error will go down from 5% to 1%. And the type 2 error, you will see that it will increase from 0.2% to a higher value, because type 1 and type 2 error are negatively correlated errors. So you can see type 1 error decreased 0.01, which is 1%, and type 2 error increased from 0.2% to 1.9%. That's it for this video. Until next video, enjoy business analytics.